All right, at least you can start that timer. I'm ready. All right, so I'm going to talk about the Crossplane project, which is an open source project. And so I work at a company called Upbound, one of the founding engineers there. And we open sourced Crossplane about 4 or 5 days before the last KubeCon in Seattle. So we're a little bit less sleep deprived this talk here, but I definitely want to jump into it and talk about what it is. So Crossplane is it's a multi-cloud control plane. So the name comes from cross-cloud control planes. That's where we came up with the name on it. So it's based on the Kubernetes engine. So we're not rewriting an entire orchestration system. We think that there's a lot of lessons from container orchestration in Kubernetes that you can apply to multi-cloud scenarios as well. So basically, one way to look at this is that all the different cloud provider services and infrastructure, like Amazon's relational database service or Google's Cloud SQL, whatever it is, it brings all of those, represents them as Kubernetes resources. So you can use just one API, the Kubernetes API, kube control, the Go client, whatever it is, to manage all of your cloud provider services and infrastructure. On top of that, it also creates some abstractions to make a portability for all of your workloads. So in Kubernetes, if you have a container, that makes it portable. But there's other things too, that the workloads or applications are made of more than just containers. So we think there's portability that we can do for those as well. So it's an open source and community-driven project. Oh, I'm going the wrong way. Let's go back this way. There we go. So quick architecture diagram. The important part here is that on the left, we have all the various ways that you can talk to Kubernetes, right? There's a client Go, there's a CLI, there's all these different dashboards, et cetera. In the middle, Crossplane, it's built on the Kubernetes architecture. We're reusing Kubernetes with the Kubernetes API, etcd, all that stuff. And then we have a set of controllers that are talking to all the clouds. So on the right here, you can see Amazon, Azure, Google Cloud, et cetera. So this one control plane is spanning all the cloud providers to be able to talk to all of them and control resources there. So we kind of talked about the portable resource abstractions. I think Kubernetes did really good with the volume abstraction, right? And so we think that we could do the same thing for other things like databases, object storage, caches, message queues, all sorts of stuff. Let's abstract those also and do the same thing that Kubernetes did for volumes for everything our applications use. Write once, run anywhere. Let's actually start being able to really mean that now. So when you're scanning or spanning all the different clouds, you can start doing some smart scheduling decisions. You can optimize on where you're going to place the applications and the resources so that first they're close together, that you can minimize on latency for them. They're close to maybe where the user wants to consume them from. And also you can start optimizing on like cost, reliability, feature sets, all sorts of things. So that when you have a control plane spanning all of these clouds, that you can start making smart choices. We talked a little bit about this in the intro talk about separation of concerns. You can have your developer, they don't have to know the details, right? They can say, I want a Postgres database. I don't really care where it comes from. The administrator can write a storage class or a resource class that defines where exactly that Postgres database is going to be. Is it going to be in Google with Cloud SQL? Is it going to be in Amazon with RDS? The administrator is the one who has to think about that. And I've got 13 seconds, and so it's an open source project on GitHub. We're super active there. We're looking for people to use it, write some issues, contribute code to it. We're happy to have new people join the community. Done.